Alrighty, let's see what we got today. Another hard one. Maximum candies you can get from boxes. You have n boxes labeled 0 to n minus 1. You can for arrays, status, candies, keys, and contained boxes where status is I is 1 if the ith box is open and 0 if it's closed. Okay. Candies at I is the number of candies in the ith box. Keys at I is the list of labels for the boxes you open after opening the ith box. A list of labels of the boxes that you can open. Huh. Okay. So you can only open other boxes. I see. So like a box has keys, and then you can unlock other boxes when you open certain boxes. Okay. Contained boxes is a list of boxes you found in the ith box. Oh, okay. So certain boxes have keys, or every box has some number of keys and some number of other boxes inside it. You're given an integer. Huh. So it's like maybe I think of it more like doors. Like certain doors open to rooms that have certain keys and are connected to other doors in that room. Okay. You're given an integer array initial boxes that contains the labels. So these are like your initial doors that you can open. You can take all the candies in any open box, and you can use the keys in it to open new boxes. You can also use the boxes you find in it. Return the maximum number of candies you can get following the above rules. Interesting. So initially boxes index 0 and 2 are open. They have 4 and 7 candies, 7 and 4 candies. Box 2 also has box 1 inside it, and no, box 2 has keys for box 1 inside it, and I think this is easier if I think about these with doors and room than keys, but box 0 has box 1 and 2. Initially you only have box 0. So you start with box 0, you get to box 1 and 2. Box 2 is already open, you find the key for box 1 in it, and then you open box 1. And box 1 has box 3. I don't think you have the key to box 3, it doesn't look like. And box 3 is initially closed, so I think you should get 754. Yeah, okay, 754. This is a lot of layers. This is a lot of layers. But it seems like you just work with a bunch of sets, maybe, and you work it in a particular order. Like maybe you have a queue. Yeah, I assume you just have a queue, and then you go through the boxes that you opened. You open more boxes. You get more keys. I guess the issue is like maybe at a certain time you have certain rooms that you open. One room gets the box, one room gets the key, and the sequencing of it matters. Maybe you always the sequencing of it matters. Okay, I think this is a queue. So So let's say answer is initially 0 number of candies. I'll have a double-ended queue to keep track of which rooms I've opened, and I think it initially starts with the initial boxes. Initial boxes. I mean, I don't think there's a particular order that you go through them, so you just put them all in the queue. Or there shouldn't be like a order preference that you know of for now. And then I think you need a set of keys, like you need a set of keys. Okay. All these things maybe you need a set for them so that you can quickly, I guess you don't need a set for status, but I think you need a set for keys because you're always adding to that set. Or maybe you need a keys array. Maybe you just need a keys array. Let's say n is the number of rooms, n is the number of boxes, which is the same thing as the length of any of these things. Yeah, because the keys array being something that indexes by the box number rather than by like this thing is giving just like which boxes contains what keys. I want to know whether or not I have certain keys. Maybe I have has key array, and this is going to be initially 0. Yeah, for everything, let's say it's false. For every room or for every box, and maybe I have a has box as well. And maybe I need to set my has box to be true based on which initial boxes I have. So for B in initial boxes, has box of this thing is going to be true. Status. I guess you need to have a has open or is open. No, status is or yet. Status is or yet. So based on the index, I can see if it's open using status, if it has the key using has key, if it has the, if I even have the box using has box. Okay, so I can go through while there is a deck. Pop the current box from it. Box is deck.pop left. So what am I going to do with this box? If the box isn't open, then it's just not going to work. So if status of the box, maybe I can check to see if I can open the box. So the status of the box is true, or I have the key to the box. Well, I need to actually have the box. No, everything in the queue I have a box for. So I have these things in the boxes. Maybe I need to do a scene, like a scene set. Or I do a done set, like I've done this room, so therefore don't try adding candies from this room anymore. So let's say done is equal to false times n. And if I've done this room, if box is in the done, or not sets, so done of this box is true, then keep on going. And then, so I could be dealing with a box that is like not open, or I don't have the key for, or I could be dealing with a box for the first time that is opened. So if the status of the box is true, which means it's opened, or or I have the key to the box. Keys to the box. Has key of this box is true. And then I want to add to my answer the candies of this box. I'll set the status of the box to be true, regardless. I'll say done for this box is true. And I also want to, I guess everything that I wonder if I should set the has key to the box to be true anyways. If it's already open, it's equivalent to being done or having a key for it. So I think maybe this is fine as well. Like, the key is irrelevant if it's an open box, so this might as well be true. Has key. And I want to go through all the boxes that it contains and then add them to the queue and set their status. So for every any in contained boxes of this box, I'll go and add the any to the deck. Well, I guess I don't care if the any is already done. So if any is if done of any is true, then continue. Otherwise, I will do deck.add append this any box so that I know I need to process that box later on. And then I need to do sort of the contained keys for every let's say any box. If any box is done, then do that. If any box is done, then do that. Otherwise, append any box. If any key and keys of this box is there, then I'll just automatically say has key of this any key is going to be true. Okay, so now it still has an issue, I think, of the cat and the mouse problem in terms of, or not the catch, it's like a catch-22 problem where, or maybe it's just like a timing issue, like certain boxes will open certain other boxes and other boxes open certain keys. And if you get access to a key after you already got access, or before you got access to, if you got access to the key after you get access to a box, I guess maybe you can say, So when you get access to the key, later on you get access to the box, then this should be fine. But if you get access to the box and later on you get access to the key, then you need to check for that. So if the box that's related to this key is not done, if any key not in done, then I'm going to add this to the deck as well. So it's a way of denoting that I need to check this thing, whether or not this box has been accessed at some later point. I think that might be it. And then return the answer. Actually, I don't. Yeah, return the answer. If any boxes in contained boxes. Oh, misspelled it. Contain capital B boxes. Alright, so my answer was 11 and it should have been 16 here. So I just got the 5 and the 4, it looks like. So what was it initially doing here? So let's go ahead and just print out each time box and the remaining deck. Okay, so initially it's doing 0. Okay, so box 0 where there's nothing else in the queue. And then it's going to push onto it box 1. And then next time it does box 1. Box 0 pushes onto it 1, 2. And then the next time it does 1, which means the queue is still 2. 1 does what? 1 should push onto it 3. Why doesn't 1 push onto it 3? Oh, because the key for 1 is in 2. So it basically skips 3. Then it does 2, or it doesn't. So 1 does 1. It's a false statement here. It's not opened, and you don't have the key to 1. So you can't access the stuff inside 1. So then it skips it and then does 2. So when it does 2, it should add the key to box 1. Add the key to box 1. And box 1 is already set to be done. I see. No. Let me go and print this thing. Cannot access this box. Maybe I should say cannot open this box. Okay. So it can't open box 1. So when it does box 2, adds the candy to box 2, sets all these things to true for box 2. Box 2 doesn't contain anything. Box 2 has the key to box 1. This box 1. So why does it add onto the queue to do box 1 again? this box 1 shouldn't have been done at that point, I don't think. Let me go ahead and put done as finish as well. Okay, so after the first go, box 0 is done. Here, box 1 is not done. Oh my god. It's not a set. It's not a set. Done of any key is if, oh, this should be not. Should be not. If it's not done of any key, then add the any key to the queue. Okay, there we go. Oh shit, I need to get rid of this print. Okay, so actually now I don't need to put the print. It's not fully correct. Okay. So I have 111. So I start with box 1. Box 1 has box 0 and 2, which are already opened. No, sorry, box 1 has the keys to box 0 and 2, but it doesn't actually open box 0 and 2. If the status of the box is this, I see. Because I add the key so that it checks it later on, but then the check later on needs to actually still check to see if I have that box. Okay, it could be like a different reason why I have this in the queue. I was initially assuming that everything in the queue I had the box for, but that's not necessarily the case. So what is the case? So it could be that is in the queue because I have the key, or in the queue because of the box. So if the status of the box is opened, or the status of the box has to be open, has to be there. Status of the box has to be. So I could not have the box actually. I guess that's why I have a has box, which I never used. Has box. I don't think I actually used that array at all. Yep. So if it's done, continue, or not has box, then skip this box. Otherwise, we have the box. Okay. So for every any box, if it's in done, then keep on going. I will make has box for this box true. Yeah. Okay. Okay, now we're going backwards in time. So, oh my gosh, it has box for any box. It's true. Okay, that worked. Maybe get rid of this print. Answer. Oh. Oof. Okay. Not bad. Well, not great either, but not bad. I guess maybe I need to think about how to optimize this a little bit. So I have my initial deck of boxes that I'm going through, queue of boxes. I have some record of what keys I have. I have some records of which boxes I actually have. And how many boxes are there? Up to 1,000. And I have a record of which boxes I've done. I initially set the boxes I have to be true, and I put those boxes into the queue. While deck, take the top box off. If it's been done, or I don't have it for some reason, but it's still in the queue, and skip it. Otherwise, if the box is open, or I have the key to the box, and at this point I have to have the box, then it's you get the candies from the box, you set to true that it's been done, that the status of the box is now true. I wonder when I have the key. What status? What is this? Status is opened. Okay, so if the box was closed before, I just open it with the key. Guess that really doesn't matter. Yeah, I don't think this matters. Let me double check if that one line is still fully correct. It's fully correct. I went slower. Excellent. Okay. But anyways, so I get the candies from the box. I say the box is now done. I say have to keep the box ready. Any boxes contained in boxes. If the box is done, then skip it. Okay. Otherwise, I say I have the box. Now that I have it, and I append I guess maybe you can do a check. Maybe you have a set of things that are in. No. You can have a queue and a set and not add certain things to the queue if it's redundant, maybe. If it's done, has box. I guess if I say here, like, if has box of any box, if not, if you don't have it already, then have it and add it to the queue. So you only do it once and not multiple times. And then you do it once when you get the box, and then you do it another time if you get the key. So for any key and keys a box. And maybe you can do this once as well. do it once for adding the key, you do it once for adding the box. If not has key of any key, then any key has key of any key is true. And append check again for this box. Alright, I think this is correct. See if it still works. Yeah, it's just the redundant stuff that you don't necessarily always need to add it every single time. Just when you're toggling the status of the key or status of the box. Alright, I'm going to assume that this is not a just random variation, that last change actually improved things. And I will say that is as clean as I'm going to be able to make it. I guess maybe you can make this into it looks slightly easier, slightly less indented if you do like if has key of any key, continue, and then make the other stuff unindented, and then same thing here. I guess maybe here, can you combine these into one? I don't think you can actually. I think they're separate if statements. If like you could have it done, you could have it not done. Yeah, I don't think you can combine it to one. One continue. Can you not? So you continue if either the case. Otherwise, is it possible for it to be not done? I'm thinking whether or not you can combine these to continue the negation of this thing into continue and add it to this thing. For every any box, either you have it done or actually, yeah, you can. Has box, any box, continue. Otherwise, do this. This is like the post. Oh yeah, this is exact if statement. This one. So logically, it probably should work. Right. If it's logically kind of comparable, then it probably is either both sound or both unsound. Ooh, random variation. Still on the higher end. Okay. Yeah, this was definitely. I'm not sure why these certain ones seem hard labeled, but are very much simpler than a lot of ones. I think the issue with this one is like you need to keep track of a bunch of different layers to the operations, but none of the layers are that terrible. Okay, so summary. Keep track of a lot of different levels of access, or it's not levels, it's types of access to the boxes. So basically, if the boxes, if you have box, have key is open, which requires both openable and have a systematic way of going through the boxes slash keys that do not that resolve any time conflicts. So like if you get key after access after getting box, or vice versa, or if you get the box before you get the key. No, that's the same actually. If you get the key before the box, or if you get the box before the key. Get key 5 before box 5 versus after. In both those ways, you still need to be able to get the candies from it, and then like the stuff inside the box needs to be added to the thing. So I think the most straightforward method is to use arrays to arrays size n to track which boxes keys are found, and a queue to process the box numbers in queue while processing queue. Check that there is appropriate access to the box. So again, have the box and have the key. And when opening box, add elements to the has box has key, and add the new box numbers to queue. So that was this stuff, right? So when I process a box from the queue, I double check that I even have the box, because it's possible that I have like just the key and not the box itself. And then if the box is already open, or if I have to key the box, and at this point I have to have the box as well if it's not stopping here, then I basically process the box, get the candies, get the, I don't think this is, I think this has key is actually necessary, because I do a check here, but I go through all the inner boxes and all the inner keys and add them to the list, and then add process or add onto the queue any boxes if it's a new thing that I haven't seen. So note, rather than add every inner box and inner key for kind of optimization, reducing redundancy in queue. Check that only add those numbers to the queue if toggling the state of has box has key. So only if I basically didn't have the box before and I'm saying the has box to be true, then I add it to queue. And only if I didn't have the key before, I'm saying the key to be true, I add the key. Because you only really need to do it once, right? It could be like, it could be something where all the rooms have room 1 in it, and you only need to like think about room 1 once. So time complexity, this can be O of n for processing each room, and at most each room can be added twice to the queue. Once when you have the box, once when you have the key. You can add more than that. Each room can only be added to the queue at most twice, once when have box and once when have key. And otherwise it's like n rooms, n times you need to process each thing. And space complexity is going to be also open for the queue.